Hey guys, this is the start of chapter 8. So this is 8.1. This is our chapter on sequences and series, which is really just patterns of numbers. We're going to look at different patterns of numbers. I really like this chapter, especially this section. You'll do well if you think of it kind of just as a puzzle. Okay, kind of a puzzle, something to solve. Maybe try a couple things, see what works. Okay, so that's what we're going to do. I'm going to work 10 different problems. In the first section, I'm going to work problems 1 and 5. In the next section, I'm going to work problems 8, 9, 12, and 14. In the next section, I'm doing problems 16 and 20. And then in this last section right here, numbers 23 and 26. And hopefully that addresses at least one of each type of problem you're going to see. But of course, if you have any questions on other types of problems, maybe something I missed that didn't go over, something that's a little different, please send me a remind text and I'll be happy to work with you individually on that. All right, well, let's get started. Stop the share and go over my paper here. All right, so number 1 says we're finding the first 5 terms. N is the term number, okay? So the first term is going to be a sub 1. That means first term. And all I do is take 1, plug it into N. 1 minus 3. 1 minus 3 is negative 2. There's the first term. The second term would be a sub 2. Plug 2 in for N. 2 minus 3 is negative 1. Find the third term. Plug 3 in for N. 3 minus 3 is 0. And remember I said this is all about patterns. Well, let's look, what's my pattern? Negative 2, negative 1, 0. They're going up by 1s because really this is linear with a slope of positive 1. So I'm going to say, oh, well, looking at my pattern, a sub 4, the next number has to be 1. A sub 5, the next number has to be 2. There's my first 5 terms. Let's come over here to this one. This one was a little more complex. A sub 1 equals, well, again, plug 1 in for N. So 2 to the 2 times 1. 2 times 1 is 2. 2 to the second power is 4. I'll plug 2 in. A to the 2 times 2. Okay. Probably going to start breaking my calculator out in a second. 2 times 2 is 4, so I have 2 to the 4th power. And you know what, actually, let's just leave them like this. I'm going to rewrite this one as 2 squared. Let's just leave them in this form. This will be fine. Because that'll help me see my pattern a little better. What is a, next one's going to be 3. So I have 2 to the 2 times 3, which is 2 to the 6th. And now I can see my pattern. I have 2 to the 2nd, 2 to the 4th, 2 to the 6th. The exponents are just going up by even numbers. So a to the 4 is going to be 2 to the 8th, a to the 5th, 2 to the 10th power. And yes, I could plug each of those into my calculator to get a number, but once I get right around here, I'm going to get like a super big number. I'm perfectly okay just leaving it like that. All right, number 8. So this starts the section. It says to first describe what's the pattern, write the next term, and then write a rule. So they want you to write a rule like the rules in the first 6 problems. Okay. So let's first look at our pattern. What's our pattern number? So we go from here to here. Well, I go up by 2, up by 6, up by, oh, what is that? 16? Anyway, not much of a pattern there. But 1, 3, 9, 27. These are exponents of the number 3. This is 3 to the 0, or maybe better yet. What's 1 times 3? 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So I'm multiplying by 3. I just multiply the previous number by 3. There's a good description. Okay. Now, what's my next term? Well, if I multiply 27 by 3, so multiply that by 3, my next term, I'll call it a sub 1, 2, 3, 4. A sub 4, my fourth term, would be 81. And then what is my rule? Well, let's think about this. This is a sub 1, a sub 2, a sub 3, 1, 2, 3. This is a sub 4. The next term's a sub 5. See, I messed that up. There we go. A sub 5. Can you count? All right. So a sub 5 is 81. So I want to be able to plug 1 into my rule and get 1 out. Plug 2 in, get 3. 3 and get 9. 4 and get 27. 5 and 81. Keep going. My rule is going to start off as a sub n. Okay. Now, whenever I'm multiplying, this means I'm exponential. Okay. So I'm going to say, what am I multiplying by? In this case, I'm multiplying by 3. So I know I'm going to have 3 to an exponent. Now, my variable isn't going to be x. My variable is n. I'll start off with saying, well, what if I just did 3 to the n? Well, 3 to the n works pretty well, except if I plug 1 in, I get 3, not 1. If I plug 2 in, I get 9. 3 in, I get 27. 4 in, I get 51. So they give me the right numbers of the next term. I want to be able to back it up one term. So this is what I'm going to do. I'm going to say n minus 1. Well, now if I plug 1 in, 1 minus 1 is 0. 3 to the 0 is 1. If I plug 2 in, 2 minus 1 is 1. 3 to the first power is 3. And then I can keep plugging those values in for n, and it gives me the correct numbers. So that's the correct rule. All right, move on to number 9. I have 1.5, 3, 4.5, 6. Well, what is my pattern? Well, I can look at this one. This is maybe a little simpler pattern. I just add 1.5. Keep adding 1.5 over and over and over again. Okay, so what's my next term? Well, 6 plus 1.5 gives me 7.5. So a sub 5, 7.5. Now, because I'm just adding, this is a linear problem. So I can say a sub n equals, and because it's linear, whatever I keep going up by, that's my slope. Well, I'm going up by 1.5. So I'm going to say 1.5 n. And then sometimes I have to put a number here to add or subtract so that I can start at the right spot. But I don't think I'm going to have to do that this time, because this is my first term. This is a sub 1, a sub 2, a sub 3, a sub 4. Well, if I plug 1 in here, 1 times 1.5 is 1.5. 2 times 1.5 is 3. 3 times 1.5 is 4.5. 4 gives me 6, and so on and so forth. So that rule right there works. Let's move on to this one. This one's a little tricky because it's going up linear in that, 5, 10, 15, 20, if I look at just the values, but it's changing signs, okay? So let's ignore the fact that it's changing signs for just a second. Say, okay, well, if it was just 5, 10, 15, 20, what would I do? Okay. Oh, sorry, no, I'm getting ahead of myself. The pattern is up by 5, alternate signs. Okay. What's the next term? 5, 10, 15, 20, 25 would be the next one. This is going negative, positive, negative, positive. It would be negative. So a sub 5, negative 25. There we go. Oh, now I can go on to make my rule. All right. Well, again, the numbers are going up by 5. So that's linear in that it's just going to be 5n. Well, let's see. If I plug 1 in for n, I get 5. 2 in, I get 10. 3n, I get negative 15. 4n, I get 20. 5n, I get 25. So that works to give me just the number. The problem is I really want it to alternate between positive and negative. So this is what we're going to do. I'm going to put negative 1 to the n power. Negative 1 to the n power. This is what helps me change signs, because negative 1 to an exponent is always going to give me either positive 1 or negative 1, and it flips based on whether n's an even number or an odd number. So negative 1 to the first power is going to be negative. It's going to make this negative. Negative 1 to the second power is going to be even, because negative squared is positive. If I make it 3, it's going to be negative. If I make it 4, it's going to be positive. If I make that 5, it's going to be negative. All right, but it's still just going to be 1, so it's not going to change the value. It's just going to alternate the signs. So I use this whenever I want my signs to alternate, but I don't want to change the value. Let's say, though, I wanted to start at a positive and go positive, negative, positive, negative. Well, all I would have to do is say n minus 1, or even n plus 1. Doesn't really matter. And that would give me alternating signs starting at positive. Okay. Move on to number 14. So here, the top stays at 3. The bottom goes 2, 4, 6, 8. Okay, so I'm going up by 2's. So let's think, what's my pattern? The pattern is top stays at 3. The denominator, or the bottom, goes up by 2. All right. What's my next number? Well, 2, 4, 6, 8, 10. The next one would be 3 over 10. So 8's are 5. 3 over 10. And then what's my rule? 8's again. Equals. Okay. Well, the top number staying the same. It's just a 3. So I'm going to start off with, I said a 3. And what did I do to it? Well, again, because I'm not changing that 3, I'm multiplying it by 1 over something. Because again, I don't want the top to say. I'm going to say 1 times 3 is 3. What's this going to be? Well, it's going up by 2's. So I'm going to put 2 in. And what would that give me? Well, if I put 1 in here, 1 times 2 is 2. If I put 2 in here, 2 times 2 is 4. Put in 3, 2 times 3 is 6. And if I put in 4, 2 times 4 is 8. And so that rule works for number 14. Now, I probably should have mentioned this. These are the rules that I used, okay? This doesn't mean that that is the only way I could have done this. There are other rules you could have used that still work, okay, different. There probably could be broken down to be the same thing, but there are different ways that I could write those out. So don't think this is just like one magical thing for each problem. Okay, sometimes there's different ways you can write a rule that still works. Okay. All right, so what we've done up to this point is talk about sequences. That means numbers divided by commas. Okay, those are sequences. A series is when I start adding those numbers all together. Okay, so we're still talking about patterns. The only difference is now we're going to add all those numbers together rather than just divide them by commas. So this is now talking about a series. Okay, so these little, it's called a sigma. People think of it as like an E-looking thing. This means I add everything up. All right. So I'm actually going to go backwards. I'm going to do 23 and 26 first, and then go back and do 16 and 20, because I think they'll make more sense after you see how to do 23 and 20. All right, so what this symbol means is I'm just going to take this number. This is my starting point. This is my end. I'll write that down. This is my start. This is my end. And we go up by ones. So we're not going by decimal fractions, we're going by whole numbers. I take my starting number and plug it in for that variable. Those two variables should match up. In this case, my variable is I. Doesn't matter what letter they use. Plug 1 in for I. So my first number, if I plug 1 in, 1 times 6. Okay. And always plus. I'm always adding them all together. Well, what number comes after 1? 2 comes after 1. 6 times 2. After 2 comes 3. 6 times 3. After 3 comes 4. 6 times 4. After 4 comes 5. 6 times 5. And I'm stopping there because that's my end point right there. Okay. Now I just need to figure out what each one of those things are. Well, that's 6 plus 12 plus 18 plus 24 plus 30. All right, let's add these together. 8, 9, 10, and then 4 and 6 make another 10, so I'm going to be a 0. All right, so those 2 10s are 2, 3 is 5, 6, 7, 8, 9. So if I add them together, I get 90. I add those in my head, so it's fairly likely that I made a mistake there. Adding those together, if you want to plug in the calculator and check my work, you can. Okay, so that's how I do that. Right. What about number 26? Well, same way. I'm going to plug 1 in. All right, 1 squared minus 3. 1 squared minus 3. 2 squared minus 3. 3 squared minus 3. 4 squared minus 3. 5 squared minus 3. 6 squared minus 3. Well, what if I play this thing? Well, what's 1 squared? 1 squared is 1 minus 3. That's negative 2. 2 squared is 4 minus 3 is 1. 9 minus 3, 6. 16 minus 3 is 13. 25 minus 3 is 22. 36 minus 3 is 33. All right, let's add all these up. So I have 3, we'll do 3's, plus 2 is 5, 8, 9, 10, 11, 12, 13, 14, 15, go backwards 2, that gives me 13, so 13, carry the 1, 3, 4, 5, 6, 7. I came up with 73, and I added those together. Okay, stay on at the end, and I will show you a shortcut way of doing that on the calculator, but I wanted to show those out like that because that way they show what we're really doing. Okay, so now let's look back here. It wants me to go backwards. It wants me to just write this out like one of those. So that means first thing I'm going to do, write my little E looking thing and say, okay, what's my pattern? 4, 8, 12, 16, 20. Oh, they're going up by 4. Okay, so I have 4 in. Well, let's see if that works. Plug 1 in, I get 4, 2 in, 8, 3 in, 12, 4 in, 16, 5 in, 20. All right, well, what number did I start with? I started with 1. I'm using the letter N here. You could use whatever letter you want, just so long as you make sure you use the same letter here. So my starting number was 1, 2, 3, 4, 5 was my ending number. And there you go. I just wrote summation notation for that series. Let's come over here. Now notice this one ends in dot, 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 meaning it goes on forever. And that's okay. You can do that with summation. What's my pattern then? I got 1 over 5, 1 over 25, 1 over 125, 1 over 625. What's my pattern? Well, I'm multiplying by 5. When I'm multiplying by 5, that means I have exponential. So I'm going to have 1 over 5. And it's exponential, so it needs to be to the n power. Well, does that work? Well, if I have 1 over 5 to the first power, I get 1/5. If I put a 2 here, 1 squared is still 2, 1 squared is still 2. 1 squared is still 1. 5 squared is 25. If I make this a 3, I get 1 over 125, make it a 4, 1 over 625. So yes, that works as long as I start at n equals 1. What am I going up to? Well, I said it ends in dot, dot, dot. So that means it goes up forever. It doesn't end. So I'm going to put the infinity symbol on top to show that it starts at 1, goes up forever. All right. Now, I did tell you that I was going to show you a shortcut way of doing 23 and 26. And this will be a good way of checking. Remember, I did those two numbers in my head. I just kind of wrote them out. I didn't plug them in the calculator. So this will give me a way of checking those as well. So let's come over here. All right. So which ones did we do? We did numbers 23 and 26. So we'll bring up my TI-84 calculator. It's going to be important. I'm going to try to bring up my TI-84 calculator if it decides it wants to come up. Oh, there we go. All right. Oh, I brought it to me again. All right, 23. First one I did was right here. So I'm going to hit the math button, go up, and I see number 0 is summation, the little symbol, and I can just plug in my values. Now, instead of using whatever letter they use, I always use the X button right beside the alpha. But everything else, I'm just going to plug in just like I see it in number 23. 6x. Hit enter. 90. Oh, look at there. I did that one right. Let's try this again. Math. Go up to number 0. X. So we're on 26 this time. So there's 1. We're ending at 6. And we're doing x squared minus 3. Does it work? 73. There you go. See, I can still do arithmetic. There you go. All right, and that's it for number 8.1. Again, if you have a question on your homework, please send me a non-text, and I'll try to help you out best I can.